Few men even consider the possibility of life on other planets. And yet, across the gulf of space, minds immeasurably superior to ours regarded this Earth with envious eyes. And slowly and surely, they drew their plans against us.
United States military aircraft conducting lawful military activities outside national airspace.
Guarda, ma che è? Ah, si è diviso, guarda che sta. Oh, uno è volato via. Guarda, si sta a muovere.
C'ho paura.
Guarda, ce n'è uno piccolo che gli gira attorno. Guarda, sta scappando via verso il lago. Guarda che storia. Mamma, che dato. Guarda, si sta a muovere.
C'ho paura.
Guarda, ce n'è uno piccolo che gli gira attorno. Piccolo che gli gira attorno. Piccolo che gli gira attorno. Che gli gira attorno.
years, scientists have been exploring space in search of exoplanets that hold the possibility of life. The science community struck gold in 2016 when researchers at the European Southern Observatory discovered Proxima b, an Earth-sized exoplanet. 6 years after its discovery, scientists have stumbled on something more exciting on Proxima b thanks to the more sophisticated James Webb Space Telescope, JWST. What is this mind-blowing discovery that scientists missed in their early observations of the exoplanet? And how habitable is Proxima b for life? Join us in today's video as we explore the topic: scientists' insane new discovery on Proxima b after 6 years. Although scientists have suspected that exoplanets existed as far back as 1917, it was not until 1992 that they finally confirmed it to be true, thanks to researchers at Arecibo Observatory in Puerto Rico. Over the years, there have been over 5,000 confirmed exoplanets in over 4,000 planetary systems, and we have sought to learn more about the composition, environmental conditions, and potential for life on these planets. However, one exoplanet that continues to stand out and has kept scientists busy with research is Proxima b. It wouldn't be wrong to call Proxima b, also known as Proxima Centauri b, an enigma. Here is the reason. Despite all that has been discovered about this celestial body, there is still a lot that scientists have yet to uncover. Proxima b is among the exoplanets that have fascinated astronomers for years. When viewed through the high-tech cameras of sophisticated telescopes, the exoplanet can be found orbiting within the habitable zone of the red dwarf star Proxima Centauri. Proxima Centauri is no regular star. It is the closest star to the Sun and part of the larger triple star system, Alpha Centauri. From the data obtained from numerous observations, scientists tell us that Proxima b is one of the closest known exoplanets to the solar system. The discovery story of Proxima b cannot be told without mentioning the European Southern Observatory, ESO. The European Southern Observatory, ESO, is an intergovernmental research organisation born from the realisation that nations needed to collaborate when it comes to astronomy and space research. The organisation is home to 16 member states, and its primary focus is ground-based astronomy. Established in 1962, ESO has made available to astronomers state-of-the-art research facilities and access to the southern sky. Although the organisation has its headquarters in Germany, its telescopes and observatories are in northern Chile. These resources paved the way for the discovery of Proxima b on August 24, 2016. To tell this story well, we must mention scientists' obsession with Proxima Centauri. For a long time, researchers have suspected that the Proxima Centauri star might be home to exoplanets that could hold the possibility of life. Thus, they searched for these exoplanets, and it led them to the doorstep of Proxima b. However, this journey wasn't easy because, between 2008 and 2009, initial studies spoke against the possibility of larger-than-Earth exoplanets in the habitable zone of the star. Nevertheless, some astronomers were undeterred and kept researching the subject. They were motivated by the fact that earlier observations using instruments from the European Southern Observatory had pointed out anomalies in Proxima Centauri. It became more confusing when these anomalies couldn't be explained by flares or chromospheric activity of the star. Thus, they were forced to assume that an exoplanet may orbit Proxima Centauri. Sometime in January 2016, a team of astronomers came together and launched the Pale Red Dot project to confirm whether this hypothetical exoplanet existed. Ultimately, their curiosity paid off because on August 24, 2016, the team proposed that a terrestrial exoplanet in the habitable zone of Proxima Centauri could explain these anomalies. Thus, the team led by Anglada Escudé announced the discovery of Proxima b. The team had been working under the European Southern Observatory, adding another research win to the organisation's numerous laurels. Since the discovery of Proxima b was made public, a series of observations have been performed on the exoplanet, which has yielded insight into the physical characteristics of the planet. From calculations, astronomers discovered that Proxima b is 4.2 light-years from our planet. So far, it is honoured to be the closest exoplanet to the Earth. Spatial data have revealed that the exoplanet orbits its star every 11.186 Earth days. It performs this activity at a distance of 0.049 astronomical units. It is still unclear whether Proxima b has an eccentricity because, as of 2021, there is no sign that this planet does. Nevertheless, astronomers believe the planet is unlikely to have any obliquity. Another essential information that has eluded scientists is the age of this exoplanet. Scientists have yet to determine the age of Proxima b and have been left with speculations. In Proxima b's case, researchers cannot predict its age based on that of its parent star, Proxima Centauri. This is because Alpha Centauri may have captured Proxima Centauri itself, and thus the exoplanet may not be of the same age as the latter two pair, which are about 5 billion years old. In addition, scientists say that it is unlikely for Proxima b to have stable orbits for moons. Proxima's mystery extends to its radius because it is poorly known and hard to determine. Scientists would give anything to have full information about the composition of this planet, as there is still a lot they don't know. They have barely scratched the surface in this area. However, depending on the composition, the exoplanet could range from a Mercury-like planet with a large core to a very rich water planet. Researchers are still trying to figure out the iron, silicon, and magnesium ratios of the planet. These ratios may pave the way for determining the planet's composition. This is because the ratios of these elements are expected to match the ratios of planetary bodies in the Proxima Centauri. In a bid to make up for the little that is known about Proxima b, scientists resorted to making simulations of its properties. By making these simulations and models, researchers have been able to assume Earth-like compositions. More so, these simulations extended to the predictions of the galactic environment, internal heat generation from radioactive decay and magnetic induction heating, planetary rotation, the effects of stellar rotation, the number of volatile species the planet consists of, and the changes of these parameters over time. Over time, scientists have concluded that Proxima b likely developed under different conditions from Earth. They also believe it achieved this with less water, stronger impacts, and faster overall development than our planet. Nevertheless, these conclusions are based on the assumption that the planet was formed farther than its current distance from the parent star. Some researchers have reason to believe that Proxima b didn't form at its current distance to the Proxima Centauri star. This inference is based on the fact that the amount of material in the protoplanetary disk would be insufficient. They have an alternative hypothesis as to how the exoplanet was formed. Proxima b might have been created at larger distances before it moved to its current orbit in its star's habitable zone. Also, the type of precursor material of the planet hints that it may be rich in volatiles. One hypothesis about Proxima b that many scientists seem to agree on is that the planet may be tidally locked to the host star. If it were a one orbit, the same side of the planet would always face the parent star. When astronomers were asked, they informed the world that they were unsure whether habitable conditions could arise under such circumstances. This is because a one tidal lock scenario would lead to an extreme climate where only one part of the planet is habitable. Nevertheless, some researchers have warned that we shouldn't jump to conclusions and believe that Proxima b is tidally locked. They are optimistic that if the planet's eccentricity were higher than 0.1, it would tend to enter a Mercury like 3.2 resonance or higher order resonances such as 2. 1. More so, additional planets around Proxima Centauri and interactions with Alpha Centauri could excite higher eccentricities. Now, scientists are hopeful that if Proxima b isn't symmetrical, it could be captured into a non-tidally locked orbit despite having low eccentricity. From the picture painted by astronomers, a non-tidally locked Proxima Centauri means that the planet's mantle would experience tidal heating. In addition, the planet would experience increased volcanic activity, and there is a possibility that this would cause a shutdown of a magnetic field generating dynamo. Although this picture might seem gloomy, scientists have revealed an open clause in these possibilities. According to researchers, the exact dynamics are dependent on the internal structure of the planet and its evolution in response to tidal heating. Data provided by the high-tech telescopes of the European Southern Observatory showed that Proxima b is located within the classical habitable zone of its parent star. Speaking of Proxima Centauri, the host star is a red dwarf that radiates only about 0.005% of the visible light the Sun does. More so, the star radiates an average of about 0.017% of the Sun's energy. Although this is low radiation, there is no need to worry on behalf of Proxima b because it has a close orbit. This close orbit enables the planet to receive about 70% of the amount of infrared energy that the Earth receives from the Sun. Proxima Centauri belongs to a multiple star system, which comprises other members such as Alpha Centauri A and Alpha Centauri B. The latter two form a binary star system. Scientists discovered that Proxima Centauri is also a flare star, with its luminosity at times varying by a factor of 100 over hours. Proxima b's position in its star's habitable zone means it receives about 65% of the Earth's irradiation. From astronomers' investigations, the planet's equilibrium temperature is estimated to be about 234 Kelvin. The climate of Proxima b is affected by varying factors such as its orbital properties, the spectrum of radiation emitted by its parent star, and the behavior of clouds and hazes. Like with other areas of the exoplanet, Proxima Centauri's atmosphere is still a puzzle waiting to be solved. Scientists have done their best to piece together this puzzle, but they are limited by the sophistication of the telescopes available for investigating the planet. Instead, they have been forced to develop hypotheses on what the planet's atmosphere might look like. Currently, two possible scenarios depict Proxima's atmosphere. In one scenario, the planet's water could have condensed, and the hydrogen would have been lost to space. This would have only left oxygen and carbon dioxide in the atmosphere after the planet's early history. It is also possible that Proxima b has a primordial hydrogen atmosphere or formed farther away from its star, which would have reduced the escape of water. Therefore, Proxima b may have retained its water beyond its early history. More so, if an atmosphere exists, it will likely contain oxygen-bearing gases such as oxygen and carbon dioxide. In collaboration with the star's magnetic activity, they would give rise to auroras that could be observed from Earth if the planet has a magnetic field. Scientists have employed the same climate models, including general circulation models used for Earth's climate, to simulate the properties of Proxima's atmosphere. Now, the outcome of these simulation models depends on properties such as whether the planet is tidally locked and the amount of water and carbon dioxide present. From these models, researchers have outlined some scenarios ranging from a planet partially or wholly covered with ice, planet-wide or small oceans, or only dry land, and combinations between these. The models hint at having lobster-shaped areas with liquid water or a subsurface ocean with a thin ice cover in some places. When astronomers dug further, they found out that Proxima's climate was affected by additional factors such as the nature of convection, the distribution of continents that can sustain a carbonate-silicate cycle, and ocean heat transport that broadens the space for habitable climates. Further factors include the planet's rotational period, which influences Rossby wave dynamics, internal heat flow, which can melt the bases of ice sheets, and sea ice dynamics, which can cause a global ocean to freeze. Although the scientists working at the European Southern Observatory in Chile discovered Proxima b in 2016, they didn't have a direct image of the planet. More so, none of the ground-based telescopes at the observatory could capture a direct image of the planet, and this issue persisted for years. It was difficult to directly image the planet because its separation from Proxima Centauri was too small. As of 2021, all the surveys that were performed failed to find evidence of any transits of Proxima Centauri b. The game changer in this story is the emergence of a superior space-based observatory known as the James Webb Space Telescope, JWST. The launch of the JWST by NASA on December 25, 2021, paved the way for scientists to finally view objects that are too old, distant, or faint for preceding telescopes, such as the Hubble telescope. The telescope is equipped to perform investigations across many fields of astronomy and cosmology, such as observation of the first stars, the formation of the first galaxies, and the detailed atmospheric characterization of potentially habitable exoplanets. Astronomers wasted no time deploying the James Webb Telescope to investigate Proxima b. Researchers have sought for long to obtain a direct image of the exoplanet, and the appearance of the Webb Telescope provided a window of opportunity. The JWST didn't disappoint astronomers' expectations and soon provided the scientific community with an incredible photo of the exoplanet. Using infrared astronomy, the Webb telescope gave scientists enough infrared images of Proxima b to observe for months. By studying these images and their patterns, scientists have begun investigating deeper and might soon confirm if water is present in the exoplanet or if it has an atmosphere. The discovery of water and an atmosphere would mean that there is a high possibility that the planet could sustain life. For a long time, scientists have toyed with the idea that Proxima b might be habitable due to its closeness to the Earth and similarities to our planet. This explains why much time and effort has been spent researching the planet. Although a lot of difficulty was experienced during the first 6 years of this research journey, the JWST's recent images have provided a silver lining that motivates scientists to keep pushing on. Scientists are optimistic that an atmosphere exists in the exoplanet. The presence of an atmosphere in Proxima b means that the planet could be shielded from intense surface heat while distributing heat to its dark sides. Although the presence of an atmosphere doesn't confirm the presence of life, it is still a good omen of the possibilities that lie on the planet. Scientists are not done with using the James Webb Telescope to investigate Proxima b. As much as researchers are glad with the infrared image proxies by the Webb Telescope, they are yet to uncover other facts about the exoplanet. Hence, the James Webb Telescope is still used to observe the Earth's close-door neighbour. From its vantage point, the JWST would employ coronagraphs to take more direct images of the planet. By doing this, scientists plan to answer questions such as the differences between winter and summer, the type of vegetation, and the rotation of weather present on the planet. However, scientists have highlighted some phenomena that might threaten the stability of the planet's atmosphere and hence its habitability. For instance, strong irradiation by UV radiation and X-rays from the parent star pose a problem to its habitability. Studies show that intense amounts of UV radiation and X-rays can evaporate an atmosphere. Proxima b has been receiving large quantities of radiation from the Earth, and it is possible that it received much more in the past. More so, stellar winds and coronal mass ejections are a bigger challenge to an atmosphere. Research has shown that the amount of stellar wind impacting Proxima b may be up to 4 to 80 times the one impacting the Earth. This is accompanied by a pressure about 10,000 times larger than the Sun's stellar wind. Another saddening possibility is that if the planet is tidally locked to its star, the atmosphere can collapse on the night side. This risk is often faced by a carbon dioxide-dominated atmosphere, although carbon dioxide glaciers could be recycled. What's intriguing is that an ice-covered Proxima Centauri b with a subsurface ocean is expected to have cryovolcanic activity at rates comparable to volcanism on Jupiter's moon, Io. This cryovolcanism would generate a thin exosphere similar to that of another of Jupiter's moons, Europa. One area of research that scientists are currently working on is the possibility of delivering water to Proxima b. Currently, some mechanisms can be used to provide water to a developing planet. From the simulation models, scientists discovered that Proxima b would have lost about 1 Earth-ocean equivalent of water or more. Despite the endless possibilities in our understanding of Proxima b, some researchers are still skeptical because of some possible setbacks to habitability. For instance, depending on its eccentricity, the planet may partially lie outside of the habitable zone during part of its orbit. Furthermore, oxygen and carbon monoxide may build up in the planet's atmosphere to toxic quantities. In addition, if oceans are present, the tides could result in flooding and drying coastal landscapes. This would then lead to triggering chemical reactions conducive to the development of life. While scientists are still working hard to learn more about Proxima b, they have begun thinking about the future. Proxima b is one of the sites that scientists consider a potential for robotic space exploration. The planet's proximity to the Earth has positioned it as a good candidate to explore robotic space missions. Astronomers plan to use these missions to study Proxima b better and uncover discoveries that might have missed the eagle eyes of the James Webb Telescope. Current initiatives like the Breakthrough Starshot project are designed to explore Proxima b in a much better way. Robotic spacecraft are bound to move closer to the planet and get information that ground-based telescopes or space observatories cannot. Although some scientists believe that Proxima b may harbour explosive cryovolcanoes and habitable subsurface oceans, there is still not much evidence to confirm if this is true. Nevertheless, we are hopeful that astronomers will strike gold in their investigation of Proxima b in the coming days. Also, we can take solace in the fact that red dwarfs like Proxima Centauri have a lifespan much longer than the Sun and up to many times the estimated age of the universe. Thus, this gives life plenty of time to develop in its exoplanet. Thanks for watching another episode of Voyager. While you're still here, make sure to click the video on your screen